Okay, so I'm just going to explain quickly how the notation works in recurrence relations, because some people have been having a bit of problem with it. Basically, if you've got a sequence like the sequence 2, 5, 8, 11, 14, something like this, then you need some algebra to refer to the different terms in the sequence. So what we do is we use the letter U, and the letter U just tells you that you're in one of these terms in the sequence. Don't know which one, but some of the terms in the sequence. Whereas if I used a letter like X or M or K, then I wouldn't be referring to one of these in this sequence. U tells me that I'm in the sequence. But obviously I need to know whether I'm first or second or third or fourth or fifth or, I don't know, 20th down here somewhere. I need to know where I am in the sequence. So the little number down the bottom, it just tells you where you are in the sequence. So usually we use an N for that, sometimes we use a K, but usually we use an N. And that number down there, the U just tells me I'm in the sequence, the little number down there tells you how far into the sequence you've actually got. Now in this one, you can see that each particular term, so say this one where N is 5 here, this one is the previous one where N was 4, add on 3. So if I knew the one before it, I would just be able to add on 3 to get to this one. Here where N is 3, it's the same pattern that the one before it where N is 2, if I add on 3, I get to this one where N is 3. So the way that we write that with algebra is that we say UN, so that's the nth term, N might be 4 or 3 or 2 or 5 or 20, that one is equal to another term in the sequence, the one before it. So instead of N is 4, N is 5, it's the one before, so whatever N is, take away 1. So here, for example, you could have N is 3, U3 is obviously 8, and so if N is 3, N minus 1 is 2, there's N is 2. So when N is 2, U2, the second term in the sequence, that's 5. And then obviously once I know what that is, I just add on 3. So this notation is the way that we actually explain how to get from one to another. You might also see it written like this, which is the same principle, but if we read what it's saying, UN plus 1. So if we take an example of N is 3, there's 3. So UN plus 1, the term in the sequence, which is, in this case, N is 3. Oh, if N is 3, then I'm looking at this one, because it's N add 1. So if N is 3, then I'm looking at N add 1 is 4. I'm looking at the fourth term, which is 11. So that says that this is equal to U, so a term in the sequence, N. Now I took N to be 3, that's why I had 3 add 1 there, which gave me the fourth term. So N is 3, and so N is 3, that's the third term, which is 8. 8 add on 3 is 11. So that's how we use the notation. The only other thing you might see is this sort of question, where it says that you want to take some of your terms, these are the terms in the sequence, it depends what N is, might be first, second, third, fourth, fifth, and we want to add them up. So obviously we need to know which ones to add up. Do we want to add up that and that and that, or that and that and that and that, or maybe we want to add up just these 3 or something. So at the bottom of the sigma sign, you will see a start number, so it might start with N is 2. So that tells you to start with N is 2. So we'd have U2, like that. And then we just literally work our way through all the way up the numbers until we get to whatever's up here. So if up here we had a 6, say, that means you just stop when you get to 6. And we're just adding them up as we go. So we've got U2, that's that one, telling us the start. N is 2. And now 3. And now 4. And 5. And 6. And that's where I stop, because I've reached the top there. So then obviously I need to know what these numbers actually are. So these are obviously all terms in the sequence, that's what the U tells me. This is the second term, the third term, the fourth term, the fifth term, the sixth term. So the second term is 5, the third term is 8, the fourth term is 11, and the fifth term is 14, and the sixth term I can see, because I have to add on 3, is 17. And then you would add them up. But I'm not going to add them up because I'm too tired. And I'd probably add it up wrong. So hopefully that's made it a little bit clearer what the numbers mean. I'm going to do one example for you, which is quite a complicated one, to show you how it can work in an exam. So it's un plus 2 is mun plus 1 plus un, and they tell us that u1 is 2 and u2 is 5 and u4 is 21. That's all we know. So I'm going to put this information into these equations. So for example, I'm going to take n is 1 first of all. So this will be u1 on the end. N is 1. Here n is 1, so 1 add 1 is 2. So this will be u2 there. And here n is still 1 obviously, so 1 add 2 is 3. So I get this equation here. Now u1, that's the term in the sequence number 1, first term, that's 2. I know that already. u2, that's the term in the sequence that comes second, apparently that's 5, I already know that. I'll put the m on the other side. So now I know what the third term in the sequence is, almost. It's 5m add 2. So that's the third term in the sequence. What about the fourth term? Well, the fourth term, if I was writing u4, then I would be having a 4 here instead of n plus 2. So if n plus 2 is 4, then I must be using an n which is 2. So I can put that in here and here. u4 is n is 2, so 2 add 1 is 3, so it's u3, and then n is 2, so u2. So it's the second term, add m lots of the third term is equal to the fourth term. But I know this, it's not 2, it's 5. I know that's 5. And I know this as well, that's 5m add 2. The third term I already worked out was 5m add 2. So I can put this in. u3, that's the third term, that's 5m add 2. And u2, that's the second term, that's 5. So tidying it up a little bit, 5m squared add 2m add 5. So that's the fourth term, and I know that the fourth term is 21 because they tell me that in the question. So this is equal to 21. So rearranging 5m squared